All right, so we are on to video part 2. Again, you are allowed to work on the notes yourself, but you can go through the video to check your answers. So you have to go through the notes, videos, whether you watch the entire thing or skip through it is fine, but you do need to watch. And especially if you miss one, you need to go back and actually go through my instructions. Okay? All right, so next question, practice. Is the rate increasing or decreasing? Well, if we're going from left to right, you notice it's going upward, right? So that means it is doing what? Increasing. All right, what is the rate of change? So we're going to find a couple points. This point is a good point to use because it is at an intersection, so it's at the very start. This is not a good point because I'm not sure. Is that 2.5? Is that 2.4? I'm not sure, so we don't want to use that one. We also don't want to use this because is that 4.7, 4.8? Not sure. So we need to make sure that it's at an intersection. So if you notice, this one here is perfectly at the number 10 and perfectly at the number 5. So I'm going to go ahead and use this point. So remember, step 1 is you rise. So we're going from 0, and what number did we stop at? So rise, we went up 10. Even though it's 2 boxes, we actually rose 10 and we went up, so that's positive. Okay, and then we're going to go ahead and now run because you're going from point to point. So we're going to run from 0, and then what number did we end at? Well, that number's 5, so from 0 to 5. So 1, 2, 3, 4, 5. So this one is by ones. So that would be positive because we're going to the right, so that's positive 5. And then we're going to use Desmos to simplify 10 over 5, and we get 2. 2 what? 2 centimeters per what? Second. Okay. Okay, next one. Is the rate increasing or decreasing? So from the left to the right, if you notice, from left to right, it is moving in which direction? Up. So that means it is a increase. Good. Now it says, what is the constant rate of speed for the Smith family? So if you notice, I'm going to read this: distance traveled by the Smiths. This is my number of miles, and this is the number of hours. That helps me write my rate of change. So I'm going to find 2 points. I'm going to use my origin because that one's pretty easy to use. Can't use that, so I'm going to keep looking until I can find a point of intersection, which looks like it's up way up here. So I'm going to look. From 0, I'm rising. What number did I stop at? Even though I traveled only 1, 2, 3, 4, 5 boxes, right? That's not 5. How many did I travel up to? I traveled up to what number? What number is that? 50. Okay, and then I'm going to run. So from here, I'm going to keep going until I get to this point because that's my goal. So how many is that? So we went from 0 and then we stopped at what number? What number is that? 2. So even though I went 4 boxes, that's not 4. That's actually only to the number 2. So we went to the right 2. So 50 over 2. So we're, oops, excuse me, that's not a 2. So we're going to use Desmos to simplify that, 50 over 2, and it will give me 25. 25 what? Miles per what? Hour. So they traveled at 25 miles per hour. So they were traveling pretty slowly. Definitely not like me. All right, next one. Find the slope using the change in y values. Y's are the second number in the table. Rise over the change in the x values, which is the run. So we're going to see how far did we change from 2 to negative 2. So from 2 to negative 2, that means I went down in value, right? So how much did we go down in value? Well, we went down by 4. Let's make sure. From negative 2 to negative 6 is also going down by 4. So what is our change in the y's? Well, our change in the y is negative 4. Now we're going to do our change in the x. So how do we go from 9 to 3? If you notice, 9's down to 3 means we're going down in value. How much? We're going down by 6. Are we going down by 6 again? Yes, we're still going down by 6. Okay, so we're subtracting 6 each time. So that means our run was negative 6. And make sure you always do what? Simplify. We'll put into Desmos, and it becomes a positive 2/3 because double negatives make positive. Okay, find the unit rate for the water passing over the dam. So this top number is always going to be our X. The bottom one is always going to be our Y. So always first in the table is your X value. Always second is going to be your Y value. So we're going to find the Y's first. So how far did we go from 4 to 8? Did we go up or down in value? Well, we went up. How much did we go up? We went up by 4. We went up by 4. So what is our change? We can keep going and verifying, but every time it's going up by 4. So our change in our Y values, which is the rise, is 4. Now we're going to check how much for our X values. Well, did we go up or down from 3 to 6? Well, we went up by how much? We went up by 3. By 3. By 3. By 3, right? So our run is going to be 3. And we're going to put that in Desmos just to make sure that it simplifies, which it does. It's 4/3. And so we're going to say 4/3, or if you put it as a decimal, that'd be 1.3 repeating, which is fine for a rate. You can do it as a fraction or as a decimal. 1.3, let's say, what? Feet per time in seconds. Okay. Next one, find the unit rate of distance over time. So the first thing we're going to do is we're going to find the change in Y. Did we go up or down? From 96 to 91, we went down. How much did we go down by? 5. If we went down 5 again, would we get to 86? Yes. So first thing I might want to know is what number is there, because that's what it's asking here, right? So what number would go down if I went back down by 5? Well, what's 86 minus 5? 81. So I know my rate on the numerator for my rise is the y's and the minus 5. And then we're going to do what is our change in the x, the run. From 8 to 11, did we go up or down? We went up. How much did we go up? 8, 9, 10, 11. So that's 3, right? Did we add 3 here? Yes. We added 3 there. So yes, each time we were adding 3. We're going to put it in Desmos to make sure that it doesn't simplify, and that does not simplify. Again, you can put it as a decimal because it's a rate of change, or you could simply leave it as the fraction. Okay, find the slope of the given table. So feel free at any point to pause, try it yourself, and then check if you got it right. So we're going to find the change in y's first. So how far did I go from 2 to 2? Did I go up or down? Well, I didn't do either. I didn't change at all. So what did we add? Nothing. We added nothing, right? So 0. So 0 is the numerator. Now we're going to change the denominator. We went from -3 to -1. So we went up in value. How much did we go up? We went up by 2. We went up by 2. From 1 to 3, we could add 2 and we get 3, right? So my run is 2. We're going to always put it in what? Desmos, hopefully you said. So 0 over 2 in Desmos will simplify to 0. So my slope is 0. And if I actually graph that real quick, so -3 to -1, 2, 1, 2, 3, 2, and I graph that line, I don't know if you notice it's a 0 slope because there's no steepness. It's flat, it's horizontal. It's another way you can try to do that type of problem. Okay. All right, go ahead and stop and go ahead and get to the next video.